Let's now look at solve linear inequalities in one variable. Remember, we solve them like we solve linear equations, except for the possibility of, on the last step, multiplying or dividing by a negative. Then we reverse the inequality symbol. Okay, so here we need to solve 6x is greater than negative 30, which we would proceed the same way as if this were 6x equal negative 30. So we are ready to divide both sides by 6, okay? Divide by 6, divide by 6. We solve this for x is greater than, do the division, negative 5. Now that's a solution, but it's different from an equation because the equation often has one solution. X is greater than negative 5. There are lots and lots of numbers greater than negative 5. So we might be interested in showing the solution in some other ways. The solution set, this is one good way to show the solution set. We could also show it as a graph. Okay, here's the solution. We could show it as a graph. Okay, for one variable we could use one number line, and we would find the number negative 5 wherever it is, mark it, and we'd decide whether to include it or not. Let's see, because of greater than negative 5, well, negative 5 itself is not greater than negative 5, so we don't include it. But which way do we shade? Which has numbers that are greater than negative 5, the right side or the left side? Well, we know that numbers get greater as they go to the right, so we know that greater than this number would shade to the right. And we said we do not include it, so a parenthesis will help us in the next way we might want to write this. The other way we might want to write the solution set is called interval notation. Alright, and to write the interval notation, the graph itself can help us. We want to write a starting number and an ending number, so reading the graph left to right is how we start. Read the graph left to right. The first number we see is negative 5. The last number we see, well, we don't see it because it keeps going in this direction. So we have to remember what is on this end of the number line. We call this the infinity end. Okay, it's in the positive direction. So the last thing we can name here is infinity, and we separate those by commas. Now, the number negative 5 is not included because it says not exactly negative 5, only greater than negative 5. So we open that with a parenthesis just like our graph. And an infinity always takes a parenthesis, so that's interval notation. Okay, that one solved very quickly. Let's solve another linear inequality. 15y plus 15 is greater than 5 times the quantity 2y plus 2. So again, like in an equation, we would want to clear the parentheses first. So 15y plus 15 is greater than, distribute here, 10y plus 10. And now begin to, let's see, we'll eliminate the y term on this side. It would take a minus 10y, or adding a negative 10y to both sides. Then we could collect here, this gives us 5y plus 15 is greater than 10. And now let's eliminate the constant on this side. We'd take a minus 15, or adding a negative 15. It gives us 5y is greater than 10 minus 15 is negative 5. We're going to divide both sides by 5, and that gives us y is greater than negative 1. Right, and again, that's a good way to state the solution set. Lots of numbers greater than negative 1. Some other ways we might want to show that in graph form. So one number line and find the number negative 1. Okay, and shade to the right of negative 1. Alright, and again we'd need a parenthesis here. So let's go back and say, what if this were or equal to? Or equal to. Would that change things? Yes, it would change it for our graph. This is greater than or equal to -1, so we could include -1. Okay. And again, if we want to write the interval notation, we would begin with -1, we end with infinity, reading that left to right. We do include -1, so it's a bracket to open, and infinity always gets a parenthesis. It shows the solution set in several different ways.